All right, so hi everybody. Welcome to the first AP Stats office hours. If you're here, hello. If you're watching the recording, hello to you as well. I've tried to design this so that it should be pretty good for you watching. This week is going to be mostly kind of a lecture since I figured attendance might be a little slimmer. So I'll kind of go through Unit 1, and then I'll have time at the end for questions if you have any. So without further ado, let us get started. Okay. So, let me open like that. All right. So, as always, usual, follow us on our social media if you're watching this to see updates for what we're doing. We've got tons of new courses, mini courses, college admissions, that kind of thing. So in this stream, first kind of basic introduction and welcome, and then I'll kind of talk about, why take stats, or, because, obviously you're taking stats, but why it's worth it for you to take stats, and what makes AP Stats unique as opposed to other AP classes, and then do a quick review or preview, depending on how far you are, of Unit 1, and then have some open question time. So first about me, my name is Sander, and I am from Michigan, West Michigan. I'm a college freshman, and when I'm not, I've been working for Five Bowl since last summer. Love pretty much every second of it. And when I'm not, working on things here, you can find me reading. I also enjoy geography and language, and I also am a musician, so you'll find me composing or playing the piano or organ. So first of all, why take stats? And I think that stats is probably one of the, if not the most practically relevant course to your life. And I mean that because it actually plays a fair bit into, what we might call adulting. So it kind of allows you to develop these just basic literacy skills that allow you to see things and evaluate them, and just kind of understand data in the world around us, because you see data a lot in the news, and especially these days in politics. So it allows you to see, if data is trying to mislead you or what it's actually representing. And also, it's a different kind of math. It's not as calculation focused as like calculus or any of those other math courses. It's more about kind of conveying your knowledge and how you can write about math. So the computations that you'll end up doing, even in later units, it goes no real farther than things you can do after an Algebra 1 class. There's nothing really that tricky about the math and statistics, and a lot of it you end up doing on your calculator, or you're using tables anyway. And finally, as always, college credit, just like any other AP class. So what makes AP Stats as a class unique? It, like most other AP exams, is still MCQ plus FRQ, but the FRQ is graded a little bit differently, and I think it's a little bit advantageous because basically your FRQ grade is graded on a 4-point scale. But each part of an FRQ, since, as in most classes, FRQs are made up of more than 1 point, it's either marked as essentially correct, partially correct, or incorrect. And you can mess up one or two things, little things, to get an essentially correct score. Partially correct means you've got a good idea of what you're doing, but you maybe messed up the execution of it, and then incorrect means it's completely wrong, or you have very little idea. But each FRQ then is graded based on how many of each of those marks you got for each part. So for example, a 4 might be everything essentially correct with maybe 1 partially correct. So that scoring means that as long as you are thorough and show your work, even if you aren't sure of a little thing, you're bound to receive pretty much some credit. So always write down if you have a vague idea, because that means you can get it partially correct, at least on the exam. I don't know what your teachers do, but at least on the exam for FRQs, write everything definitely isn't wrong. And another thing is that you get a formula sheet. So you do not have to memorize really any formulas for this exam. You only have to memorize when to use them and how to use them. So if you look at the formula sheet, I wish I had it pulled up, but it basically gives you every formula that you will need for the exam. But it doesn't give you any explanation beyond that. And sometimes it gives you general formulas in words, and then you've got to substitute the relevant statistic. And, of course, you'll learn what goes where later. But that's one of kind of the nicest parts of AP Stats, is that you don't have to memorize any formulas. You just have to memorize when to use them and how to use them. And another thing is it's all about conveying that you know the math. So a lot of it relies on, wording things well and having precise terminology. And that's kind of an interesting part that makes AP Stats a lot less like a math class and maybe more like a humanities class, in that there are certain ways you have to know how to convey what you're talking about. And so that makes it, pretty interesting, in that it's not necessarily about the computations. More of it lies in how you can convey that data, because that's what statistics is really about, conveying information. All right, so now you may or may not, from the poll I sent out a couple of weeks ago, it looks like most people are working through Unit 1 or haven't started yet. So I just thought I'd do, a brief review or preview of Unit 1. So Unit 1 is kind of all about one variable data. And so I guess the biggest tenet of statistics that you must know is numbers and statistics need a meaningful context. So that's kind of what statistics is all about, is taking data and providing meaningful numbers to represent it. So you've probably learned this, but a variable is just something that changes that you're measuring. And variables are, broadly speaking, divided into two categories: categorical and quantitative. So a categorical variable is something that is grouped into names or values. So when you record the value of that variable, you're recording a name or a value. Whereas quantitative variables take on a numerical value. So so first we're going to look at categorical data. So there are two basic ways you can represent categorical data. So that's a frequency table and a relative frequency table. So for this hypothetical set of data, I've just made up some numbers based on what your favorite milk flavor is, plain chocolate or strawberry. I don't know if your school still has strawberry milk. It is less common, and I think for good reason. But frequency table, so in a frequency table, you're giving the number of responses to that in each category. So you can see here in our table, out of 50 people surveyed, 24 liked plain white milk, 20 liked chocolate milk the best, and 6 liked strawberry the best. And the thing to note about a frequency table is a lot of it depends, or a lot of kind of comprehension and understanding of the data hinges on knowing the total, because like we said before, numbers are kind of meaningless without any sort of context to put them in. Whereas a relative frequency table is a table by the proportion in a category. So you can see here 0.48 prefer plain milk, 0.40 prefer chocolate, and 0.12 prefer strawberry. And kind of the important thing to note about relative frequency tables is that those are given as proportions, not percents. So all you have to do is take your frequency and divide it by the total. And another kind of interesting thing to note is I purposely chose nice numbers, but sometimes if you add up all of the relative frequencies, it should sum to about 1, but it won't always sum to 1 due to rounding. This is something that you can do if you look at any sort of proportion distribution in like a newspaper or whatever, and if you add them up, they won't always add up to 1, and that's just because you generally round each value individually. So representing categorical data in terms of graphs. So the most common way you'll see this done is with a bar chart. And so that's just really simple. You've probably been doing this since, I think I first did in second grade, you just have one axis with your categories and the other axis with the count. And the real advantage of a bar chart, of course, is that you can put multiple pieces of data on them, and you can compare frequencies really easily. So you can see here I've expanded my data set to include preferences from another high school, for instance, and so you can compare those and you can see which high school, the comparisons between different sets of data, and it allows you to compare them based on each category. So now moving on to quantitative data. So there are, broadly speaking, two types of quantitative data, and this is kind of one of the first things in statistics that can get a little tricky until you understand it. So you've got discrete variables, which means they are only able to take on a countable number of values. And you might say, wait, hang on, aren't those categorical values? No, because the difference between a discrete quantitative variable and a categorical variable is that discrete quantitative variables are still represented by numbers. It just can only take on specific values. This is opposed to a continuous quantitative variable, where it's able to take on infinitely many values. And so kind of, if you look at these examples, this might kind of help. So points scored in a basketball game. Well, you count points, and you assign a number to it. So that makes it a quantitative variable. But it's discrete because you can't score 0.1 of a point, or 0.5 of a point, or pi points. It is only able to take on a whole number value, or a positive integer value. Ice cream flavors, again, this is kind of a classic example of a categorical variable where you've got, each flavor is a category. You can't really assign a number to that. Long jump distance, however, is a continuous variable, because theoretically, however precise your measuring equipment is, you can measure it down to a specific data or a specific number, so that makes it continuous. It's not like you automatically, it's not like there are only like specific options for how far you can long jump. So I guess that's kind of the best way to think of the difference between these, is first think, can you represent this as a number? If you can, then it's quantitative, and think, are there specific options? And if there are specific options, that makes it discrete. Or think, can you have a fractional one? That's typically a very good example, because generally counts of things are going to be discrete, whereas measurements of things are going to be continuous. This one's a bit of a tricky one. The number of people who like strawberry ice cream in a study. That is not actually a variable, because that's not a factor on which you're measuring. That is actually a statistic. And mile time, again, that's continuous, because theoretically there's a set time, even if you can't measure it exactly, at which you run a mile. And it's not like there are kind of specific, it's not like you can only run a 4-minute or a 5-minute mile. All right, so there are kind of 4 main ways in AP statistics we represent quantitative data. So we have a histogram, where we have, and you might think, well, isn't histograms for categorical data, because that's how, or aren't these sort of bar graphs for categorical data because you're dividing them into chunks? Well, no, because if you look at a histogram, what that's doing is it's taking all values in between two specific points and putting them into a box. So this graph, for example, of arrivals per minute and frequency, you can see that each box is 0.5, is half a minute. And the width of these boxes kind of determines how precise your histogram is. And so if you make the variables wider, obviously your histogram will show more of a general trend rather than a specific trend. Then over here we have a stem and leaf plot. And so how to read a stem and leaf plot is that you look at the first, first of all, there would be a key up here that would say like 0, line 5 equals 0.5. So that will tell you the stem is the ones place, and then the leaves here are the tenths place. So this is 0.5, 0.7, 0.8, and so on. And the real advantage of a stem and leaf plot is that you can kind of see what the general distribution of values is, while still being able to see the specific values themselves. This is kind of as opposed to a histogram, in which you can see the frequency of values, but you're still limited by that box. You can't see exactly what things are. Then down here, we've got a cumulative frequency graph, which basically shows, so we've got whatever we're measuring here, and then we've got the frequency on the y-axis up to the total. So basically, why it's called a cumulative frequency graph is because it shows how many are up to that point. So if we look at this graph, for instance, of the heights of Boy Scouts, we can see that at 150 centimeters, that is about 35 out of the total 60 are below that height. So this can also be represented as a proportion on the y-axis, but basically the advantage here is it kind of allows you to see where most of the data can fall in kind of a different way by looking at how quickly it increases. And then finally, we have a dot plot, which is where we take our values and then we see how many fall into those categories. So it's a bit like a histogram, but just using discrete dots. Okay, so now we have how to describe a quantitative graph and variable, and this is kind of where a lot of this new terminology comes in. So the phrase that I always use, you've seen me use it in the channel before, is CUSBS. So that stands for center, unusual features, shape, and spread, and be specific. Because on an AP exam, guaranteed they're going to ask you questions about describing a graph. And this can be the first sort of thing where that big piece I talked about earlier of the wording of something comes in. Like, this is a question where if you're not kind of in tune to what specifically they want, you're kind of on track to receive a lower score than what you want, just because you don't know what all to include. So these are the 4 things you should kind of include. So obviously center is where the center of the data is. You can use any sort of measure of central tendency, so mean, median, and then the shape. So this is skew. So skew is basically saying, is the graph leaning a particular way? So if it's skewed to the left, that means the left tail is stretched out. And if it's skewed to the right, that means the right tail is stretched out. And the easy way I've been taught to remember this is to use your feet. If your graph looks like your left foot, where kind of the center of the graph, or the center of the distribution, is to the right, that means it's skewed to the left. And if it looks more like your right foot, where the majority of values are towards the left, then it's skewed to the right. So you can either think about it as which tail is stretched, or you can use the feet trick. So then kind of looking at the shape now, we have this thing called modality. So that is kind of where the humps or the peaks of the graph are. So uniform is kind of just a flat line where almost every value has about the same frequency. This is as opposed to a bimodal graph where there are kind of 2 clusters, and then a unimodal has just the one kind of central. And this, gaps and clusters. Clusters is where there's lots of data. Gaps is where they're comparatively low frequency. And the other important thing to realize here is that, kind of bringing back to meaningful statistics, descriptions cannot be used to make conclusions about data. And so this kind of goes back to that whole thing you probably heard: correlation does not imply causation. So you can observe tendencies, but you can't really use them to make conclusions, since you have to actually find, significant numbers and other significant evidence to say this is actually a trend, rather than this is just what it looks like. So how do we do that? So we can kind of look at what are called summary statistics for quantitative data. So these are ways you can represent data. So a statistic is a numerical summary of data. So a statistic is just any number that represents data in some way. So, because of course it's great to have data and all, but you should have ways to kind of represent it and summarize a particular aspect of that. So we can look at statistics that show where the center of the graph is. So of course you've got the mean, which is of course the sum divided by the number of values. In statistics, we represent that with this x with this mark with this line across the top, and you say that x bar. And then the other measure of central tendency that we use is the median, and so that's simply the central value where you list them all in order, and then you find what the middle value is. If you've got an even number of values, it's the average of the two middle ones. First kind of thing that might be new to you is quartiles, which are the median of each half. So if you split it in half, take the top half, the median value of the top half will be quartile 3, median value of the bottom half will be quartile 1. And then you have the percentile, which is the percent of values that fall below, rather is the number of values or the proportion of values that that a certain percent fall below. So if you're in the 50th percentile, that means 50% of values fall below that number. Then kind of looking at measures of spread, we have range, which is max minus min, interquartile range, which is quartile 3 minus quartile 1 rather. And then we have kind of the mean-based version of that is the standard deviation. So that's given by this rather long and complicated formula from the formula sheet. But basically what this is the standard deviation of a sample is the square root of 1 over number of samples minus 1. This big E-looking thing is the Greek letter sigma, and that represents a sum, and that xi minus x bar squared. So that is just any particular value x minus the mean squared, and you add those all together. So if you've got like 1, 2, 3, 4, and 5, you take the mean there would be 1 plus 2 plus 3 plus 4 plus 5, which is going to be 15. Divided by 5, which is 3, so your mean is 3. So you would take 1 minus 3 squared, add that to 2 minus 3 squared, so on, and then put that in the rest of this formula. Again, this is where stats is a very calculator-heavy class, so you will want to have, and you will use, your trusty TI calculator or Casio equivalent of choice, and because as long as you show that you know how to do a calculation, that's great. You can actually calculate using your calculator. So you can kind of write out the formula, substituting in relevant numbers. You can put them all into a list in your calculator. And kind of speaking of that, later in the year, I'll definitely have a calculator session where I will kind of project my calculator. And we can take a look at using a lot of features on your calculator that you probably haven't used before, but are really helpful. So more summary statistics, what we call the variance is the standard deviation squared. That will come into play later as you start to do regressions and things. And then we had a question about this the other day, so determining what is an outlier. So kind of, you've probably done outliers in like middle school statistics, if you had that, if you had a sort of a statistics unit prior to algebra. We no longer kind of look at outliers visually because we need some sort of numerical test to back up our visual kind of gut. So there are two ways we do this, one based on the median and one based on the mean. So what you do is if a value falls more than 1.5 times the interquartile range above or below the median, then it's an outlier. So once you find that IQR, Q1 minus Q3, multiply that by 1.5, then add and subtract that from the median. And if a value is outside of that, then we classify it as an outlier. Alternatively, you can multiply the standard deviation by 2 and add and subtract it to the mean. That is another way you do that. That the standard deviation method it will be used to determine significance later on, whereas the IQR is generally what you're going to use in just here where you're sort of looking at data and describing it, not making any inferences from it. So then we talk about something called resistancy here. And the mean, the standard deviation, and the range are what's called non-resistant. Outliers affect them. And if you think about it, mean because we're adding and dividing. That means big numbers and small numbers tend to yank them around. Same thing with standard deviation. And the range, really obvious, because say if you've got a value that's double what the rest of the top is of a data set, then that will double your range. So those are what's called non-resistant or non-robust. So they're affected by outliers. Whereas we like to use the median and the IQR more to represent data, because that can show where the true mill value of a data set is without kind of being pulled around or affected as much by outliers. And so this is why you might see, for example, in real estate, you might see the median house price listed rather than the mean house price, because that will give you an idea of kind of if you walk up to any house, what it would look like. Because, for example, if the area has a couple of very expensive houses, that will drastically increase the mean. All right, so now how do we graph summary stats? So we look at this thing called the box plot, and this is kind of based on the 5-number summary. So we've got the minimum, quartile 1, median, quartile 3, and the maximum. So if we look at here, we can see the minimum is represented here at 15. Then we've got quartile 1, the median, quartile 3, and the maximum. And these can be displayed either horizontally or vertically. So now we can kind of see, we can compare skew by comparing the median to the mean. So if the mean is higher than the median, that means we've got a rightward skew or a positive skew, but in AP Stats you're going to use the term rightward. Because the mean is higher than the median, which means we've got data trailing off to the right, and negative skew, vice versa. And summary stats here can be used as evidence to support a conclusion, because rather than just kind of describing the appearance, they actually make a meaningful statement about the data that you can compare. And so kind of the final topic in Unit 1 is the normal distribution. And I'm planning to either record a lecture or have another office hours on it, because this is such kind of a big topic. And it's really kind of important. And this is probably the biggest topic of Unit 1. And what you learn here kind of affects what you will do throughout the rest of statistics, because it kind of introduces some of the concepts, although you won't use them until the second half of the course. It'll start to introduce you to, okay, how do we determine if a number or if a study that we have is actually showing some sort of meaningful significance? Because one of the big, and this is called inference, and because kind of one of the biggest things is, although your study may find something, you have to see if that actually means something. So, like I said, this is kind of a big, important topic, so I'm planning to do a separate thing from this. This has just been kind of a quick introduction to Unit 1. Now I'm going to stop sharing my screen, and I'm wondering if anyone has any questions about anything over Unit 1 or just anything stats in general.
Hi, I have a quick question.
Sure, go ahead.
Personally, I am not taking any kind of stats class in my school, but I'm self-studying for the AP Stats exam. So as for the class, I know that the actual class was 5, I actually signed up for the fall, but I know that it got like rescheduled, like pushed back to the spring. So like, my question for you is like, what would you suggest I do in the meantime, so like I don't like lose that much time, because I know that the exam is in May. And so my question is like, what do you think if I like start doing on like a regular basis would help me like with my goal?
Yeah, that's a really great question. And kind of the answer I would give it is, obviously the course will run in the spring. We are trying to get all courses to run in the spring, and I personally see AP Statistics doing that, as it's kind of a moderately popular class, and I expect we'll have the demand, and regardless, we will run some form of course in the spring, so definitely sign up for that. But in the meantime, I would say start learning it, even if that means reviewing at the beginning of next semester in the course. Personally, so just work through, see if you can find some sort of statistics textbook, or there are plenty of great other resources online, self-paced. So like Khan Academy, I believe, has statistics. So just kind of look through, read through the AP Statistics course and exam description, watch those AP Daily videos on Classroom, ask in the channel if you want help finding those. So just kind of get yourself familiar with the concepts, even if you aren't going to be actively learning. So that way, when you go and you actually start doing review, you can make sure that and actually start learning the material, you can know that what you're actually learning, you've got some sort of foundation for it. So whether that means going and buying a prep book, I think we may at this point, and if not, it'll be published soon, have a prep book guide on our website. I'll check after this and put the link in the AP Stats channel, and just sort of keep asking questions, keep coming to office hours. I plan to do this maybe every 1 or 2 weeks, giving kind of a summary of what everyone should have learned. So just kind of follow along, ask questions, and just make sure you're kind of familiar with everything by the time the 15-week course starts, because although that will teach you everything, I promise it will, it might be a little bit fast-paced if you don't have some sort of other support. So that's kind of my advice. Does that help?
Yeah, thank you so much.
Any other questions? Thanks, Shreya. I know other stats curriculums do things kind of differently. Like I think I started with Unit 6. So it's a bit crazy depending on what your stats textbook does, but even just following along, all of this is kind of related, and it means you might actually be able to apply skills here to all sorts of other things, because stats is kind of all about, like I said, it's all kind of tied to that big goal of communicating data. So any other questions?
I have another quick question about one of the concepts that you just spoke about today.
Oh, sure, go ahead.
About the I feel like, oh wait, it's the skew. For the skew, like how would you know exactly whether it's left or right kind of skewed? I don't know if I'm using the correct terms here, but
That's a great question. Let me share
I don't think I kind of
a
understood that. So.
whiteboard. So basically, if we've got a graph, or whoops, stats or graphs look like this, where we've got our values here and our frequency here. And say our graph looks something like this. So this graph, you can see the tail here is stretched out. So we've got a lot of values over here. So we've got a few values that come way out here. So this means this graph is skewed to the right, because there are more values out here than what a normal graph might look like more than this. You can see here that there are kind of disproportionately many values out here. So that means it's skewed to the right. And kind of conversely, if it looks like this, then this is skewed to the left, because we have all of these values down here that wouldn't be present in a normally shaped graph centered at that point. And like I said, you can kind of use the foot trick. So if the long low part is on the left, like your left foot, then it's skewed to the left. Does that help?
Yeah, thank you.
All right.
Also, I've heard of something called the bell curve. Do you know what that is? Like, could you explain that?
Yeah, so that actually ties into the thing I didn't talk about today, the
Okay.
normal distribution. And so what that basically is it's sort of like in kind of like an ideal or a kind of perfectly represented distribution, one that kind of is what data would look like if there's no kind of in other influencing factors. So definitely I'll get to the bell curve. That's kind of included in that whole concept of normality.
Okay, thank you.
Anything else?
I'm just wondering, how do you suggest I should be like just reviewing as I go? Because I did unit 1 and now I'm on unit 2. So like as I like progress through the course, how do you suggest that I should review stuff so that I don't forget what I already learned?
Are you self-studying or taking
No,
it?
I'm in the class.
Okay. So that means you will have access to, or you can ask your teacher to have access to all of those practice FRQs on AP Classroom. So I would say just kind of doing maybe like an FRQ for old units, like maybe once every new unit you learn, just to kind of make sure. Some units build on each other, so I would say like for some units you will already use the concept, but if not, I would just say do a couple of practice problems for things that you know you probably aren't going to remember, just regularly. I would say another thing is, because stats is a very kind of, I call it kind of chartable. It's really kind of easy to, make nice visual summaries or summaries. So I would just say kind of as you go, make kind of a running cheat sheet, or make your own study guides for it, just to make sure you're actually actively, writing down how you can remember this.
Okay, thank you.
All right, any last questions? All right, if there's no other questions, I really enjoyed presenting and then talking with you all. Those are some really great questions. So I will stop recording here.